Good day. As we get going on our unit equilibrium, it's very important to understand about gases because many equilibrium reactions involve gases, and we can shift reactions forward and backwards. So we want to know some of the properties of gas, and some of these date back to Science 8. So from the kinetic molecular theory, we should know that most of a gas is empty space because the particles are moving so fast and are therefore spread apart. So here we have 1 mole of carbon dioxide. If it's in a solid state, dry ice, that would occupy 28 milliliters. If we have 1 mole of carbon dioxide and we take it up to 25 degrees Celsius at 1 atmosphere pressure, it's going to have a volume of 25,000 milliliters. So that tells you going from 28 mils to 25,000 milliliters. We have almost 25,000 milliliters of empty space. Since there's empty space between the particles, it means gases are highly compressible and they will take the shape of their container. In terms of shipping gases, and there are many that are shipped, you may want to ship oxygen. Typically it's liquefied just so it takes up a lot less space. Variables affecting a gas. Well, let's say you start off with a certain mass of a gas. That will dictate the moles you have. If we take the volume and stretch the volume or shrink the volume, that will affect the gas. If we increase the external pressure or decrease it, that affects the volume. And temperature greatly affects gas as well. Avogadro's hypothesis, going back to Chemistry 11, in that case, you might remember an introduction to the mole. Equal volumes of different gases, the same temperature and pressure, contain equal numbers of particles. And what that's saying is it doesn't matter about the identity of the gas. The particles are so spread out, as long as they're not affecting each other greatly, the gases behave the same. And I had that red mole box hanging above the whiteboard, and it didn't matter. It said chlorine on carbon dioxide and hydrogen and helium and oxygen. Didn't matter. At room temperature and pressure, it's going to be 24.5 liters per mole of gas. So that's an introduction to some of the properties of a gas.